In this video, we'll discuss how to take digital surface models of fields that are derived from drone imagery and use them to calculate the height of plants in those fields, and then use the height information to determine what our canopy volumes are for the plants in the field. In previous videos, we've discussed how to make masking layers that allow you to separate plants from soil and things like that. And today we're going to take some of those same kinds of methods and apply them to digital surface models to filter between soil and canopy and get information and start making comparisons there. So the first thing that we need to do is open up our QGIS project. I already have this one loaded. And then what we need to do is add our digital surface model. Okay, so then here, DSM there is showing that that's a digital surface model. And we can full screen this. I'm going to hide some of these background layers. And now we have the digital surface model hide this grid layer as well. And we can see that we definitely have some taller plants in here shown by lighter colors. And in other areas you can see that there's plants in these small rows here, although they're not as tall as some of these other ones. So what we can do is we can take this other layer that we made earlier. It's a threshold layer. It has values of 0 wherever there's soil, and it has values of 1 wherever there's canopy. And we can start separating out those two using this raster calculator. We can start off by naming this, and I'm going to first make a layer that's just canopy data. I'm going to call that as shorthand CDSM, Canopy Digital Surface Model, and then that's okay. And then what I want to do here is take my digital surface model and then divide it by my threshold. And what this will do is wherever I have a pixel that is a plant, then that threshold pixel value will be 1, and we just get the height from the digital surface model divided by 1, which is itself. But whenever that's a 0 value, because it's soil, and that threshold, that denominator becomes 0, then we get no data. So it's going to eliminate all those pixels, and we'll just have information about the heights of plants. And I'll hit OK and let that run. Right, we can check our new layer here. We can see that it's clearly created something, and we can hide our threshold layer, but let's show the true color image. Okay, there it is. So there's the true color image in the background, and then we can see that yes, this new canopy digital surface model just has data where there was plants, and that's good. So it's just giving us height data. You can click on this, and you can see that we have some height data in there. So 307. And then we can do the same thing for just our soil values. This is going to be a little bit trickier. And so what we need to do is we need to flip those. So we already know we can take our digital surface model and we'll divide it by our threshold, but we actually need to basically flip that. So I'll put parentheses. And the way that I do this, I take my threshold value is less than, say, 0.5, and it'll go through every pixel. And if the threshold is a 0, meaning soil, then that threshold is less than 0.5. That's true. It's read in as a 1, and 1 is there in the denominator. And if it's a plant pixel, then the threshold value for that pixel is 1, and it is not less than 0.5. That becomes a 0. That's how that is read in, and we don't. We have a 0 in the denominator. We don't have any meaningful data. It's no data. So let's just, of course, name this thing. I call this soil DSM, SDSM. Save, and then we can run that. Now let's discuss how you'll get your data out of these files. So to do this, we have to use the Zonal Statistics plugin. You can do this using the processing toolbox. and find it here. And it's important that we're using this right here. So make sure that it has this right symbol. And then in here, we've gone through this before, but we need to make sure that we're choosing the right raster layer. So if we want to get data about our canopies, our plants, then let's make sure we choose the CDSM, and then make sure we have the right grid here. So if you had multiple grids, make sure that you have the right one. And then let's get the CDSM data. And usually with canopy data, I want to get information about the highest point of the plants in each plot and also the average height. And so really all I need here is usually mean and max. But really if you wanted some of these other things, you could definitely check those boxes. And that's just telling the computer what we want to download data related to. So I'll hit OK there, and then I'll hit run. Great, so that is done, and if we want, we can go here and check the results, open attribute table, and sure enough, yes, we have right here, we have the Canopy Digital Surface Model Mean and Canopy Digital Surface Model Max. I'm going to reorder this by the ID. Okay, that's great, so I will X out of that for now. And then let's do the same kind of thing for our soil values. So usually what I want to get information about is the, for me, usually like the median height of soil. So if there was like some little hill or a little dip, that's not really what I care about. I usually care about like the normal surface around the plants. And so what I usually am going to be most interested in is that median value. So I'll, again, choose my raster layer. That's going to be that soil digital surface model SDSM in my own personal notation. And then we'll get the, let's call that SDSM. And then make sure we get that median value here. And I mean, you could get mean, for example. Those are almost always really similar in my experience, but usually I'm going to use median. Okay, so just one option there. That's great, and let's get that. So let's talk about how to get those canopy areas again one more time. We can go into this zonal statistics plugin, like with the other data that we were extracting. We'll go into this threshold file, and remember that that has a 0 value for any pixel that's soil, and it has a 1 value for any pixel that's plants. And then by getting an average of a plot, then we can get a sense of how much of it is plants. And we know the size of those plots that we specified because we said how wide they'd be and how tall they'd be. So if we know the percent coverage of plants and we know the total area, we can get a sense of how big the plants are in terms of area, and we already know height. So we'll be able to do these calculations to get volume as well. So again, let's just go through this. So threshold 01, and then what we need, let's name this real quick. So canopy there, and then let's get this mean value. I don't need these other two, and then hit OK. That's all I need, and let's run that. Great, so that has now run. We can go back over to our grid. Let's open this attribute table. We can see that we have this canopy area mean. We have the median soil values. We have those mean and maximum canopy height values. That's great. Let's make sure this is ordered the way we expect. So there we go. So now we can take this entire attribute table and hit Control A to make sure it's all selected, Control C, and then take it over to something like Google Sheets or Microsoft Excel and paste it right into that. And now we know what the percent canopy area is, but we don't have it in something like meters squared. So I know based on the dimensions that I specified for my plots that they were 4.33 by 2.375 meters, and doing the math on that comes out to about 10.3 meters squared. So I'm going to go equals 10.3 meters squared times, in this case, 12% of that was canopy. So we end up with about 1.25 square meters of canopy area in plot 1. So I'll rename this as canopy area square meters, and that's great. And I double click that to bring it to the bottom. Great. And let me actually, the way I think of this usually is to have them have the area first. So I'm just going to move this over. Control X that. Cool. So that's been moved over. And now we'll take our canopy height information, or elevation information, and our soil elevation information, and we can say, for example, the mean canopy height, and then this is in meters, and then I can just take the mean canopy elevation minus the soil elevation, the median soil. So again, just where's the average height of my, or elevation at the top of my canopy? Where's the normal soil? What's the difference there? So just this minus the soil. And then we can get some value. So that's showing that those plants are on average 0.24 meters tall. Okay, that makes sense. And then we can do the same thing for the maximum height of any plants there. And then so we get that maximum canopy digital surface model value minus the soil value. You can see that maximum is much higher. So we're getting 0.64 there. So these are definitely taller plants. And then we can start making comparisons here. Let me make sure this is named properly. So that was this next one. The last one was the, let's see, max canopy height. Great. So now we have mean canopy height, we have maximum canopy height, we have the canopy area, and we can start multiplying these. I've probably said it already, but the average height of any object, so you can think of a triangle, like the average height of it, which is 1/2 of its maximum for a triangle, times the surface area, the cross-sectional surface area from the other plane. That's always going to be volume. And so we can multiply this mean canopy height times our canopy area in square meters. Those units are the same, so that's good. So meters squared times meters. And so that'll give us cubic meters, and that's our canopy volume. Cool, and that's in meters to the 3. All right, I'll double click that, bring it to the bottom. And then if we want to do some conditional formatting, for example, let's do a color scale. Let's maybe change that to that. Done. Okay. And we can see we have some real standouts. Let me change that formatting here. So I'd rather have those high values as being green. Like these are the ones that were doing really well. So yeah, some of these did really well. We had 2 cubic meters, which is a big area of plants in some of these canopies. So let's find this one if it's quick and easy. I think it's always important to check your work. So ID number 52. So here's our ID column. Let's go down to that. Remember that we can select here. That's ID number 52. Now I have that highlighted. I can go back over to my project, and if I show that grid, it'll show which plot that is. And I'm going to go back to my true color image of the field, and check this out real quick. This is the the soil digital surface model, hiding all the soil, and then you can just see plants sticking through that. And I'm going to get rid of that one as well. And boom, there are the plants. That's with the digital surface model of the soil in there. Cool. So sure enough, that plot right here that has a really high volume, that one was, we saw number 52, plot ID 52, and it has this really high standout canopy volume, as do the two below it here, and that all totally makes sense. If we look at our true color imagery, that's great. That's exactly what we'd expect. And then let's go to our digital surface model. Why not just confirm it there? Let's see. Does it look like those plants were tall? To me, it definitely does. So this is a really good result. So that should be our standout. And sure enough, that's what our color scale here is indicating, is that that's that 2 cubic meters kind of plot. And we can also start making some comparisons. This plot looked really healthy to me. So back to the true color image there. You can see that some of these other ones look much less healthy. So you can imagine if you're running a vegetation index on that, then your values are probably going to be lower. So that's something that we could compare. One thing that we haven't downloaded yet is our vegetation index data from these and with the soil mask. So we can do that pretty quickly and easily by going to the zonal statistics plugin, and then we can choose our masked excess green. We covered how to generate that in a previous video, but basically all it is raster calculator and then the excess green divided by threshold layer. And that's going to eliminate all of our soil pixels, and we'll just be looking at the canopy health information. And then I'll call this masks excess green, and let's just get the mean value there. Okay, I'll hit run. Great. And now we can go back into this attribute table. Let's copy all of this. Control-A, Control-C. Oops, let me make sure. It's always super important that this is all the way that we want. And so let's go back to here. I think when in doubt, if you have any question about whether or not the plots are what you think they are, you can do something like equals if that is equal to that. If true is 0 value. If false is 1, so that 0 is indicating that is true. So I'm checking here, and I can see that there's a lot of zeros. That means that those are the same. So my old data and my new data, like my old IDs in my list match the old IDs. Great. Okay, so these all match up. New data and old data are specifying the same thing. And I'm going to delete those columns. And then we can insert a plot, for example, by selecting our two groups of data. insert chart. Cool. And now we have a chart that's showing the canopy volume and the relationship with excess green. And you can see that there is a positive correlation there, but it's definitely also doing some plateauing as well. So as they get bigger and bigger, the relationship is with excess green is not increasing linearly. So anyway, hopefully these steps are useful for you. Just in summary, in this video we've covered how to generate the digital surface models that are filtered for just either the canopy or the soil, and then we've also talked about how to then extract height information from that and calculate volume information, and eventually compare that with other things like vegetation index data for each of your plots. So I hope you found it useful. Thanks for watching, and I'll see you next time.